Alright, so what we want to do is we want to simplify rational expressions. You want to simplify it when there's something on top and something on the bottom. And as we have looked at the ones that we just did, there was something on top and bottom, but there was no adding and subtracting. If you'll notice these problems, we've got added here, we have subtracted here, and then a bunch of things added and subtracted over here. So what we need to talk about is how we go about simplifying it when there's things that are added and subtracted. You can't just take parts of it and divide. You have to do it as a whole. So the first thing that you want to do is you want to factor anything that can be factored. And there's two big kinds of factoring that we're working with. One is the GCF, and the other is factoring like where there's a trinomial and we graph it and find the zeros. So I'll show you that as well. But looking at number 1, there's nothing to do on top because there's nothing added and subtracted. On the bottom, what I want to do is I want to find the greatest common factor. Well, 5 is the greatest common factor, so it goes outside the parentheses. And then you divide both of the things by 5 like we have done with the greatest common factor before. And when I divide 10x by 5, I get 2x. When I divide 15 by 5, I get 3. And so this is what I get when I factor the bottom. Now, we're not finished because after you factor, then you try to decide if there's anything that you can simplify. And what you do there is you look to see if there's like 2x plus 3 on top and bottom. There's not, so that stays. But then I look at the 5 and the 5x squared. And I think about simplifying that the way we've simplified before. 5 divided by 5 is just 1. So the 5's can go away. There's no x's on the bottom. That x squared on the top does not simplify with anything on the bottom. So it just stays like it is, and we get x squared over 2x plus 3. You can't ever get rid of like the 2x plus 3 unless you get rid of the whole 2x plus 3. You can't separate it. Okay? So let's look at a couple more. Let's look at number 3. So on number 3, notice there's a plus and a minus on top and bottom. So what that means is I need to figure out if there's the greatest common factor on top and bottom and then work it out, if I can. So on top, there's a 4 that will go into both the 4 and the 12. So I'm going to factor out the 4 and divide them both by 4. So 4 divided by 4 is just 1 or 1x. 12 divided by 4 is 3, so I get 4 times x plus 3. And then I want to look at the 8x minus 4y. Again, 4 will go into both of those. So I put a 4 on the outside and divide them both by 4. So that would be 2x minus y. Again, nothing inside the parentheses will go away. It stays. But there is a 4 on top and bottom. Because they're the same, I can get rid of it. And so I get x plus 3 over 2x minus y. We're going to look at a few more. Number 5. On number 5, notice on the top, there's an x in common. So I can factor out an x on the top, which just means I want to get rid of an x on each of those, so that's x plus 3. On the bottom, there's a 5 on top that is the greatest common factor between the 5x and the 15. And let's see what we have left when we divide that. 5 divided by 5 is just a 1. 15 divided by 5 is 3. Looks like we're left with x plus 3. Notice the x and the 5 is not going to go away because nothing there is in common. However, at this time, because there's a parentheses on top and bottom that's the same, I can get rid of all the x plus 3. So you can either get rid of the parts of the things that are the greatest common factor, or you can get rid of whole parentheses like that. This means that our answer is x over 5. Okay, let's look at number 7. Again, look at that. Think about the greatest common factor. The greatest common factor between 3x minus 12 is 3. I can factor out a 3, and I'm left with x minus 4, because I could divide them both by 3. On the bottom, it looks like there's an x in common, so I can factor out an x, and I'm left with, get rid of one of the x's each, so x minus 4. Looks like in this case the x minus 4's will go away. You can, like I said, get rid of things outside or get rid of whole factors. That means that we have left a 3 over x, and that's our answer. So on the first one, or on number 2, the 2a squared is going to stay. There's nothing to factor out of it. But on the bottom, 2a plus 10 looks like that you can get rid of a 2. So divide it out. Take out the greatest common factor, and so you're left with a plus 5. At that point, the only thing that can happen is those 2's can go away. Everything else has to stay. Be really, really careful. You cannot get rid of one of those a's right there, because it has to be a whole term when you get rid of things, unless there's something outside like there was at the beginning. Okay? Number 4. The greatest common factor on top is a 3x. So be careful and try to get out everything that you can that's a part of the greatest common factor. When you divide it out, you're left with 2x plus 3. On the bottom, again, I think there's a 3x that's the greatest common factor, so you'll be left with a y. And then 12 divided by 3 is 4, and then one of the x's are still there. And what you can do, because 3x is a whole thing, you can get rid of all of the 3x's. Because it all goes away. And that means that your answer is just 2a plus 3, or 2x plus 3, and y minus 4x, nothing else there will go away. Number 6. So we have an x plus 4 on the top that we can just leave. And then on the bottom, there's a 2 that I can take out as the greatest common factor. When I divide them both by 2, you get x plus 4. And this part is where it's interesting again. So the x plus 4's will go away, and you're left with that 2. But when something goes away completely on the top, that means you're left with a 1 on the top. You don't just make it go away. It's like a 1 up there, so this comes out to be 1 over 2. And then the last one on that top section, there is a y that is in common there that I can divide. You're left with x and a 2 when you take out a y. On the bottom, a 7 is in common with everything. Divide them both by 7, I still get x plus 2. X plus 2's go away, and I'm left with the y over 7. Okay, let's look at a few more. So on this first one, there's nothing to do on the top, so the top will just stay as 3y. On the bottom, there's a 3 that is in common there that I can factor out, and I'm left with y plus 2. At this point, I can get rid of those 3's, and then that y is just by itself over y plus 2. Be very, very careful. Do not get rid of those y's. And you can't do that. Anytime you're adding or subtracting something, you have to get rid of the whole thing. You can't just get rid of part of it. On number 10. So, again, the top, there's nothing to do. But let's look at the bottom. So on the bottom, they have a 2 in common and also an x. So 2x is what's going to come outside on the greatest common factor. And that means that I'm left with an x here, and then when I divide, I get a 6. Now, on this one, if you didn't realize that there was an x in common, you might have thought there's nothing to get rid of. Most of the time, there will be something on problems like this that tell you to simplify. So use that x minus 6 on the top to help you think about how to get that on the bottom if you need to. At that point, all of our x minus 6's go away. There's nothing on the top, but remember when there's nothing on the top, we let that be a 1. And then on the bottom we have a 2x. Alright, number 11. So on the top, the greatest common factor is x. And I would be left with x plus 2 when you take out an x out of each one. A 5 is in common on the bottom. So we're going to divide them both by 5, and you're left with x plus 2. At that point, all of the x plus 2's go away, and you're left with x over 5, and that is your answer. Number 12. So greatest common factor on the top is a 2. Divide them both by 2, and you're left with x minus 4. On the bottom, we can factor out a 3. Again, you're left with x minus 4. Those both go away, and you get 2/3. Alright, one more in that section I want to do with you, and then we're going to go to the next section where it looks like trinomials. So I'm going to look at 14 with you. It's pretty much the same, there's just something I want to show you real quick. So on top we've got a 10x, there's nothing to do. On the bottom, there's a 5 that I can divide or use as the greatest common factor. And whenever you divide that, you're left with x plus, divide 40 by 5, and you get 8. On the surface, it seems like there's nothing to get rid of or nothing that will cancel or factor. But because the 5 and the 10 are not one whole term, you can divide the 10 and the 5 both by 5. And when you do that, it's like you're dividing 5 by 5 and then 5 by 10, or 10 by 5. So that means that you're left with a 2 on the top. So on the top you've got 2 and then your x. On the bottom, the 5 isn't there, and you get x plus 8. Okay, so let's look at this next section. It's a little different because a lot of these look like trinomials. And what happens with trinomials is that there's not necessarily a greatest common factor. So looking at number 17 on the top, there's nothing that goes into all three of those. Same on the bottom. Well, we have been factoring these before, and so that's what we're going to look at next. When we factored these before, what we did is we put it into Desmos. So like on the top, you don't put the whole thing, you're just going to put each part separately. So I just put x squared minus 2x minus 8. We find the zeros, and then we change the signs and make factors out of them. So that's what we're going to do here. So on number 17 on the top, I got negative 2 and I got 4 for my zeros. So the way I'm going to make those factors is x plus 2, because I'm going to change the sign, and x minus 4. And then I'm going to do the same thing on the bottom. So I'm going to get rid of that one, and I'm going to put x squared plus x minus 20. I'm going to find the factors, or find the zeros, and then make them into factors. The negative 5 becomes x plus 5. The 4 becomes x minus 4. And what that means is now I can figure out if there's things on top and bottom that are the same that you can get rid of. And x minus 4s are the same. You can just get rid of the whole term. And then that leaves you, and I'm sorry I'm running out of room, but it's x plus 2 over x plus 5. You can't get rid of those x's because they're not being multiplied. They're being added, and so that makes it a little bit more complicated. Let's do a couple more of these. Look at number 18. So on the top, on number 18, you're just going to leave it as x plus 3 because you can't factor it. There's not a greatest common factor. It's not a trinomial. So I'm just going to leave that as x plus 3 on the top. But I am going to have to do something on the bottom. So that x squared plus 5x plus 6, I'm going to put into Desmos. Alright, I can tell there's some things going on. I'm going to zoom in on it a little bit and find those zeros. And my zeros are -2 and -3. Remember, what we want to do is we want to switch the signs and make factors out of them. So we're going to make it x plus 2 and x plus 3. So I made it 2 factors and then change the signs. At this point, I can now get rid of these x plus 3's. They're a whole term. On the bottom, there's an x plus 2, and what that means is on the top, because there's nothing left, that's understood to be a 1. I'm going to do a few more, and then I'm going to let you try some. So let's look at number 19. So let's go ahead and graph the top. Move it over and find those zeros. So we got 2 and 4. So we want to make them into factors and change the signs. X minus 2, x minus 4. Alright, and then I want to do the next one. 2x squared minus x minus 6. That one's interesting because we have a decimal. Okay, I know that the 2 one is going to be x minus 2, but now I've got to figure out how to deal with that decimal. Okay, so remember that what we do when there's decimals is we put the decimal in, change it to a fraction, and then we rewrite it. So what I'm going to do is I'm going to go ahead and make it x plus 3 over 2. And then in the final step, I will change it because I can tell there's not an x plus 3 over 2 on the top, so there's nothing to get rid of it. What I can get rid of are these x minus 2's because they're the same. And that leaves me with x minus 4 over, remember the 2 that's on the bottom of the fraction comes in front of the x. So that would make 2x plus 3. Just a few more to practice before I ask you to do some. Let's look at number 21. So on number 21, there's x squared plus 10x plus 25. Most of the time when we're trying to find the factors, we're looking for 2 factors here. We only got 1 factor. Okay? There's only one place that crosses the x-axis. But if you remember, we've talked about double roots before, and when you have a double root, what you do is you do the factor and then you square it, or you write it out twice. Okay? So I realize that one of the factors is going to be x plus 5 because I want to change the sign. And because it's a double root, I'm actually going to write it a second time. Instead of squaring it, I'm going to write it a second time because maybe something will go away when I factor the bottom. Alright, and then we can put the bottom in there. Find those factors, or the zeros, 5 and -5. So that means that we have an x minus 5 and an x plus 5. And what that really means is one of these x plus 5's will go away. And so you're left with x plus 5 on the top and x minus 5 on the bottom. And again, you can't get rid of any of the x's or any of the 5's because it's one whole term that's being added or subtracted. You can only get rid of it if you get rid of a whole thing. I keep saying we're going to try some, and we are. We're going to do 22 first, and then I'll let you try. So number 22. I'm going to factor that one. We get -2 and 5. So that means that I have x plus 2 and x minus 5. On the bottom, there's nothing to do except to leave it as x minus 5. The x minus 5's go away. And since there's nothing on the bottom, I've got an x plus 2 on top, and you can put it over 1 if you want to, or you can just leave it as x plus 2 since the x minus 5's go away. That's what I wanted you to see on that one. I'm not going to graph each one. I'm going to tell you what you should have gotten on a few of these, and then if you have questions, let me know. So on the top here, it's just an x minus 5 because there's nothing to factor out. On the bottom, you would have gotten a negative 6, so x plus 6, and you would have gotten a positive 5, so x minus 5, whenever you graph that. X minus 5's go away. Since everything on the top goes away, that's a 1 on the bottom, and you're left with x plus 6. Alright, on 23. Whenever you would have graphed this one, you would have gotten a negative 4 and a negative 2. So it would be x plus 2, x plus 4. On the second one, I will graph that one to show you real quick. You get x squared plus 4x plus 4. You get a negative 2 there. Notice it is a double root. So what we do is we put an x plus 2, and then we put another x plus 2 anytime that double root happens. X plus 2's go away, and you get x plus 4 over x plus 2. On 24, when you graph that one, you get a negative 4 and a negative 3. So it's x plus 4, x plus 3. Change those signs. Nothing to do on the bottom. X plus 4's go away. And then that leaves you an x plus 3. You can put it over 1, or you can just leave it as x plus 3. 25 is another one that has a double root on the bottom. On the top, if you remember what the difference of two squares is, you can do it that way, or you can just graph it. Again, the bottom is a double root, so you get a double root at negative 4. Put both of those x plus 4's. X plus 4's go away, and you get x minus 4 over x plus 4. On 26, x squared minus 29, there's a plus 3 and a negative 3, and change both of those signs. X minus 3's go away, and that leaves us with x plus 3. Okay, let's look at 31. If I graph 4x squared minus 25, I do get two fractions. Notice they're the same. One's a negative and one's a positive. Let's go ahead and change that. It's 5 halves, or 5 over 2. So it's kind of like x plus 5 over 2 and x minus 5 over 2. We can change that in just a second. Then let's go ahead and do the 2x squared minus 3x minus 5. Since I got that 5 over 2 on top, I'm going to guess there's going to be a 5 over 2 on the bottom, and there is. So the minus 1 is going to be an x plus 1, and the 2.5 there is going to be x minus 2.5, or 5 halves. I can go ahead and get rid of those, and see, I really didn't have to change it right away to know what to get rid of. But for my final answer, I do need to change this one. The 2 comes in front of the x, so that would be 2x plus 5 over x plus 1. So these problems are multiplying and dividing. It is similar to what we've been doing, it's just more stuff. Okay? It's more stuff to look at. And sometimes it helps you to remember what you did with fractions, and sometimes it does not. I'm going to try to show you what I can, and hopefully that will help you remember what you did when you used to do this with fractions. What you're going to do is factor everything that can be factored. If there's a greatest common factor, factor it out. If it's trinomial that you need to graph, graph it. If there's nothing to factor, then you leave it. And you do it at all the places. Okay? So on this one right here, the x plus 4, I'm going to leave that. And the 5x, I'm going to leave that. Okay? But there's a greatest common factor on the other two places. For example, there's a 3 in common here, so I can factor out a 3. And when I do that, I'm left with x plus 2. On the bottom here, I can factor out an x, because they both have an x in common. And I'm left with x plus 2. Now, when you try to figure out what you can get rid of, think of this, all of this as being on the top, and all of this as being on the bottom. So anything on the top, no matter which side, can get rid of with things on any part of the bottom. So if it's top and bottom directly or crossways, as long as one's on top and bottom, you can get rid of it. Okay? So, for example, this x plus 2, I can get rid of that x plus 2. Because one of them's on the top and one's on the bottom. They're just opposite places, and that's okay. Nothing else goes away. I can't get rid of anything else because nothing else is in common. Okay? So here's how I write my answer. The 3 just comes in front of the x plus 4 that's left over. You've got a 5x and another x. So what you do is you combine that, and you make that 5x squared, because there's 2 of them. There's no x plus 2 because the x plus 2 went away, and so that's your answer there. 3 times x plus 4 over 5x squared. Okay, let's look at the next one. So, I know I'm going to have to look at all 4 parts. This 4 will stay. That a plus 4 will stay. And that 8a will stay. Because none of those are anything that can be factored. There's not a greatest common factor and nothing to graph. But the a squared minus 16, we can graph. Remember, instead of a, we're going to put x when we put it in to Desmos. Negative 4 and positive 4 is what we got for our zeros. So we're going to say that that is a plus 4 and a minus 4. Alright, remember, anything on top and bottom directly or crossways can go away. So I can get rid of these a plus 4s. I can also reduce the 8 and the 4 because it's not being added. So 4 will go into 8 2 times, so I can get rid of those and put a 2 here. On top, that leaves me a 2 and an a. On the bottom, that leaves me with a minus 4. Let's do another one, and then I'm going to let you try them. So on the next one, the 2 and the 3 will stay, and it looks like maybe there's something going on at both of those parts. X squared minus 1 is one of those that we can graph. There's zeros at 1 and negative 1. So x plus 1, x minus 1. X squared minus x. Looks like there's an x in common. I don't really want to graph it because there's an x in common. I'm left with x minus 1 when I factor out the greatest common factor. And then what I can get rid of is one of these x minus 1s. And then nothing else I can get rid of. So my answer is 2 and then x plus 1. We have an x and a 3, so we're going to say that that's 3x. Okay, I have graphed all of the things we need for 36 to 38. So on 36, it looks like just that top part is the only part that needs to be graphed, so I have that for us. Looks like negative 3 and 4 are our factors, so we're going to say x plus 3 and x minus 4. X squared is just going to stay as x squared. X will stay and x minus 4 will stay. Alright, let's think about what we can get rid of. So we can get rid of the x minus 4s. One's on top and one's on bottom. You also can get rid of one of the x's because they're not being added or subtracted. So I can get rid of this x and one of these x's. And what that leaves me with is an x plus 3 on top and an x that's left over on the bottom. Okay, let's look at the next one. So we needed to graph x squared plus 5x plus 6. Looks like there's two zeros, negative 3 and 2. So that would make x plus 3 and x minus 2. The x plus 1 and the x plus 2 over here will stay the same, but we do need to graph x squared minus 1. Looks like negative 1 and 1 are our factors, or zeros, and so we're going to make that x plus 1, x minus 1. And then look again on top and bottom, decide if there's anything that you can get rid of. And it looks like the only thing you can get rid of is these x plus 1s, and so that looks kind of messy as far as an answer goes. But that's what happens. And so our answer is all of the things that are left on top combined with all of the things that are left on the bottom. And you just leave it just like that, even if it looks messy. Okay, and then the very last one. Get rid of those two. So there were several things you had to factor here. The first one was x squared plus 6x plus 8. Negative 4 and negative 2 were our factors. So there's x plus 2 and x plus 4. Okay, then it said x squared minus 4x plus 3, which is this one. 1 and 3 were our factors, so it looks like we have x minus 1 and x minus 3. Alright, on top, looks like we have that middle one. 1 and 4 are our factors. So x minus 1, x minus 4. And on the bottom, there's a greatest common factor, so they used all the kinds here. 5 goes into x plus 10, and you divide it by 5, so 5 times x plus 2. Okay, let's see what you can get rid of. I can get rid of these x plus 2s. I can get rid of these x minus 1s. And I think that's it. And so what that will leave me as an answer, it will leave me x plus 4 and x minus 4 on the top. And on the bottom, that leaves me 5 and x minus 3. Alright, last kind of problem that we need to look at are dividing problems. And the most important thing that you should remember when you're dividing is keep, change, flip. And I'm thinking that some of your middle school teachers told you that when you were dividing. Keep, change, flip. When you're multiplying, you don't have to change anything, but when you're dividing, you do. I want to show you with a couple problems that are numbers first, and then we'll go to problems that have x's with them. So looking at number 1, or 39, what that meant was you keep the first fraction, you change the divided to times, and you flip the second fraction. Now, from there, because these are just numbers, there were a couple ways that your teacher probably told you to do it. One way is just multiply it all on top, multiply it all on the bottom, and then divide. You can try to divide and simplify before that, and if that makes sense to you, go for it. If I just multiply on the top, I get 12, and multiply on the bottom, I get 2, and when I divide that, I get 6. Let's look at one more fraction with numbers, and then we'll go to the letters. So this one right here, We've got negative 5 over 6. Because we're going to keep that. We're going to change this to times. And we're going to flip that. Again, like you can multiply like we did on the last one across and then divide. The other way you can do it is easier on this problem, so that's why I wanted to show it to you. You can divide the 5 by 5 and the 35 by 5. You get a 1 there and a 7 here. You can divide the 6 and the 36 all by 6. That's a 1 and that's a 6. And then multiply. Negative 1 times 6 is negative 6. 1 times 7 is 7. That would be another way to solve it. You can either just multiply on top and get the answer in the bottom and then divide. Or you can simplify as you're going on top and bottom, kind of like what we've been doing. Let's skip on down and go to some problems that have some X's and letters with them, because I think that's the ones that are most important for what we're going to be looking at. So let's look at number 45. We're going to start with our keep, change, flip concept. Okay? So we keep the first thing, change, and flip. And when we do this one, we're kind of thinking about it the way we thought about it at the beginning of class, when we just thought about getting rid of things. There's nothing added or subtracted, so you can just get rid of anything that you can get rid of, top and bottom, since there's nothing added and subtracted. Alright, for example, I can get rid of one of these A's. So that A's still there. I can get rid of one of these B's. That B's still there. Oh, nope, I'm getting rid of that one. This one is still there. I'm sorry. And then the negative 9 and 4 stay. So I'm left with negative 9B over 4A. So keep, change, and flip. See what you can get rid of, and then go from there. Okay, let's look at another one. Number 46. Keep, change it to times, and flip it. Alright, I can get rid of these x squareds. They're exactly the same. I can also get rid of the y's. And then what that means for my answer is 7 times 3, which is 21. There's nothing here except for this 4 and then over 4. So 21 over 4. Okay. I'm going to leave a couple for you to try. Let's look at 49. So 49, we've got 3x plus 12 over x squared. Change it to times and flip it. X over x plus 4. Now, before I just start getting rid of things, I do need to decide if there's anything that needs to be factored. And on this problem, that 3x plus 12 has the greatest common factor of 3. So I am going to factor out a 3 on that part of it. Okay, and then I can get rid of things that I want to get rid of. For example, the x plus 4s will go away. One of these x's will go away, and I'm left with 1 on the bottom. So that means that what I have left for my final answer is 3 over x. Okay, let's look at 51. Alright, we're going to keep 10x over 3x minus 9. You know what? I'm going to go ahead and factor out a 3 on that. So maybe I don't have to rewrite it. So 3x minus 3. change that to times, and then flip the second one. The thing in common on the bottom will be 3x, and you're left with x minus 9. I mean 3, sorry, because I'm dividing by 3. Alright, x minus 3's will go away. The 3's go away. The 10's go away. What do I have left on top? I've got this x and this x, which makes x squared. I've got an x squared on the bottom. Guess what? All the x's go away. Everything went away. That means your answer's 1. When everything cancels out like that, then 1 is your final answer. Alright, on 47. Whenever you work this one out, you do your keep and your change and your flip. With your flip, that's kind of like being over 1. So when you flip it, it's 1 over 2xy. What happens is these xy's will go away with one of these, but that means that you're still left with an xy on the top, and then 6 times 2 leaves you with a 12 on the bottom. On 50, the only thing I can do as far as looking at these terms is that first one I can factor out a 2. I think that's an a to the third times, and then we're going to flip it so a's on top and then a plus 3. So a plus 3's will go away, and then one of these a's will go away. That means you're left with a squared on the bottom and a 2 on the top. The last one, there is some factoring that you have to do on that one. So first, if you factor x squared minus 3x minus, or plus 3x minus 10, you get 2 and negative 5. So that would be x plus 5 and x minus 2. On the bottom here, looks like we can factor out an x, and we would be left with x plus 3. Change it and flip it. So this 4x plus 12 goes on the top. There's a 4 that I can factor out, so 4 times x plus 3. And then on the bottom, we're going to factor that one. I already have it graphed for us. Notice it is a double root one. And we would make that x minus 2, x minus 2. X plus 3's go away. One of the x minus 2's go away. And that means you're left with 4x plus 5 over x and x minus